Okay, maybe I go through this question from MJC lah. So a curve has parametric equation x equal to 2t plus 1, then we have another one is y equal to 4 over t. So we are asked to show that the equation of the normal, right, to this curve at the point M with coordinate 3, 4 is given to be as such. So this 3 is your x, then this is your y. So what we want to do first is actually to determine the value of t. So the value of t, very simple. So this one just put 3. Then of course this one just put your 4. So meaning that your t value, right, apparently from your x is about t equal to 1. Then same thing for this, your t is equal to 1 as well. Why do I need the t? Because later I do the dy dx, I will need to sub in. So let's do the first part. So the first part is dy dt, right, is equal to dy dx times dx dt. So we want to differentiate dx dt first. So dx dt, right, is given to be I differentiate is 2 so dy dt, so I do a bit of manipulation, y equal to 4t negative 1, right? So your dy dt is equal to negative 4t negative 2. So of course what I will get is something like this. So I can actually get my dy dx straight away already. So I move the 2 to the very left hand side. So I will get negative 2 over t square, right, to be dy dx, which is the gradient of the so-called tangent. So I want some value. So that's where the t comes in. So our t is 1, right? So I sub in. So my dy dx is given to be negative 2 over 1 square. So this will give you about negative 2. But you can see that actually this is the gradient of a tangent. So what we want to do is actually to flip change sign. So the gradient of normal is actually equal to minus, sorry, not minus, because you flip and change sign, right? So it's half. So it's half. Then of course so we know that the normal is cutting 3, 4. So straight away I can get the answer already. So y is equal to half x plus c, right? So this is 3, 4. So 3, 4 sub inside, 4 and 3 to be as such. So 4 is equal to 3 over 2 plus c, right? So c is equal to 4 minus 1.5, 3 over 2. So it's about 2.5. So this is a c. So of course the equation of normal, right, is given to be half x plus 2.5. So let's look at the form. They want 2y equal to x plus 5. So this is the equation of normal, you just times 2. So it's 2y equal to x plus 5. So this is shown. Okay, so what I want to actually talk about is whether, for example, part 2, they say, the normal meets the curve again at point N. So assuming that there's no such question, so we want to see whether the normal cuts the curve again. So actually there are 2 methods of solving. Okay, so the first method of solving, so I don't convert the Cartesian into Cartesian first. I just do the normal trick. So I can actually just submit this thing and this thing into the equation of the tangent. So for example, so x equal to 2t plus 1. So let's just say, okay, this is a normal, right? So x is equal to 2t plus 1. Then of course y is equal to 4 over t. I want to see whether I can get another value of t. So because my t, right, I cut at t equal to 1. So if I get another value of t, means other than 1, right, I can safely say that the normal actually cuts the curve again. So let's take a look. So for example, I sub inside this thing, sub inside here, then this thing, right, sub inside here. So means I'll get 8 over t equal to 2t plus 1 plus 5. So I do the manipulation. So 8 over t, right, is equal to 2t plus 6. Then you just do a cross multiply. So 8 equal to 2t square plus 6t. And then move everything to the right hand side. So it's 2t square plus 6t minus 8 divided by 2 throughout. So t square plus 3t minus 4 is equal to 0. So apparently you can see there are 2 values of t. So t plus 4, t minus 1 is equal to 0. So you can see that t is equal to 1 or negative 4. So this is the so-called the first coordinate. I mean the so-called the first point that I cut. And then this is another point that I cut. So actually they cut. So where t is equal to negative 4. So where will the curve actually cut? Very simple. So just sub in the negative 4 inside your parametric again. So x, right, is equal to 2 bracket negative 4 plus 1. So this will give you negative 8 plus 1, negative 7. Then y is equal to 4 over negative 4, right? So it is negative 1. So this is the so-called x and y coordinate. So I will actually cut the curve again at negative 7, comma, negative 1. So that's the part 2 lah. Okay, I used another method to actually get your equation. So, okay, for this, straight away, it's quite simple to actually convert your parametric to your Cartesian. So what do I mean by that? For example, I make t the subject. So the first one, you simply just erase this first. You simply just make this. So I make t the subject. So x minus 1 equal to 2t. So t is equal to half x minus half. So that's the so-called first equation. Okay, second equation, I can also make t the subject straight away. So second equation is here. So it's t equal to 4 over y. And then you put them together because the subject is t, right? So second equation here, so put them together means that I will get half x minus half is equal to 4 over y. And then you can times 2 throughout first. So times 2 throughout, so you get x minus 1 equal to 8 over y. So you do the cross multiply, or maybe I just do this, y equal to 8 over x minus 1. So this is how we do the conversion from parametric to your Cartesian. So back to this, right, you can actually just go back to something that we learned in your secondary school, right? Because in secondary school, we always get the Cartesian. So our normal equation of norm, right, is y equal to, maybe I just use 2y equal to x plus 5. 2y equal to x plus 5. So maybe I just divide by 2. Y equal to half x plus 5 over 2. Then you sub them together. So you will still get the same result. So this one sub inside here. So means that half x plus 5 over 2 is equal to 8 over x minus 1. And then of course times 2 throughout. So this will give you x plus 5 equal to 16 x minus 1. So of course with this, right, I can actually cross multiply x plus 5 x minus 1 equal to 16. So do the expansion, rainbow expansion, x squared plus 4x minus 5 is equal to 16. So this is 16. So move everything to the left hand side, right? It's x squared plus 4x, then this is minus 21 is equal to 0. So definitely, right? So x plus 7, x minus 3 is equal to 0. So x is equal to 3 or minus 7. So our minus 7 is the so-called the new intersection. So I just want to show you how there are actually two different ways. So if let's just say it's very hard to convert to your Cartesian, maybe you can just do the normal way. So you do the normal way, just sub inside, you should be able to get the same result. So negative 4 you sub inside, you will get x coordinate to be your negative 7. And of course after you sub x negative 7 into the thing, right, then you can get the y coordinate. So of course for this question, right, you can actually do the Cartesian, you will still get the same result. So you can see that the x coordinate is negative 7, then you sub inside the so-called equation of the tangent, y equal to half x plus 5 over 2. So you sub inside here, so y should be equal to should be equal to your minus 1. Yep. So this is minus 1. So these are the two different ways.